Hey everybody! It's finally not so damn hot. The room doesn't smell as bad as it did last week. All that good stuff. So, week 6. So we've only got 3 more classes left, including tonight. So we're almost done with the course, really. So here's what I'd like to do tonight. Open it up with Prime Minister's questions, as always. Then I want to spend the first half of the class diving into GWT. So last week we talked, and what I heard from you guys is like, hey, we're just getting started on the REST API. Want to do more about that. And I know that a lot of you are still finishing up Project 4, and that's cool because we extended the due date, so it's due on Friday. But I want to make sure that you're prepared to do the Google Web Toolkit stuff. So tonight I'm going to deep dive into it. I know it might be the forefront of your mind, but please pay attention and ask questions as best you can. And that way you'll have a resource that you can go back to on over the weekend or whenever you start diving into the into GWT in depth. And so we'll do that for the first half of class, and then the second half of the class, I'd like to. I guess I put it on last week. Sorry. I'd like to start one of those code katas again. I got a piece of feedback. I had several of you in your survey say, "Hey, I kind of like that pair programming stuff. Let's try that again." So cool. We'll do that, and we'll start the kata this week, and we'll finish it off next week. So to start us off, though, what can I tell you? What are some of the questions that are on your mind? Yes.
As far as the Project 4 is concerned, if we encounter an error, like say, we know that they're going to do a get search request based on their command line parameters. Can we throw that error on the client side, or must we display like a field not found error from the server?
Okay, so the question is about error handling in Project 4. Right, because the error could occur on the server. And so what happens if there's an error that occurs on the server? So let's talk about projects 1, 2, and 3 first. So when an error occurred, what did you do? How do you convey that to the user? Gracefully, yes. So with a tutu and pirouette, yes. But more specifically, print stuff to standard error, right? That's the tools that you had on the command line. That is the interface that you have with the user. You have the command line, which consists of standard out and the command line arguments and standard error is also standard input. We didn't use that though. So that's the interface that you have. Okay. If you're writing a web server, what is the interface that you have with the user, with the client? Browser, right. You have the HTTP response. What's in the HTTP response? A status code and content and a body. So that's what you've got to work with. So when there's an error, the way you express that back to the user, back to the client, is through the error code, and so the response code, the HTTP status code, and so you want to use something in the 400 or 500 range, and then where appropriate, sending back more information about what went wrong in the content of the response.
So, what if I am, for example, catching those errors when I parse my command line output before I even send the request?
Okay, so if you encounter the error before you even send the request, well, okay, then you're on the client side, right? And so then you would use the tools for communication they have there. So, right? So again, standard error. So if you you inputted a malformed date. Tell the user that. Don't make the call. Pretty much the same thing as projects 1, 2, and 3. Cool. Yeah.
So if you return a status code error, is it okay to print the code itself plus the message that makes sense?
So does it help to print the code? If you are the user of software, do you want to see the HTTP error code? Probably not. It's good for you, the programmer. That's good to know.
Your example showed it, is why I was wondering about that.
I wouldn't do that. To me, that's akin to showing the stack trace. right? It's sort of internal stuff that you may or may not want right? I mean, we all hate it when you use a website and you get like, 404 not found. We know what that means, but the user, most users don't. So, again, think about who is using the software. In this case, it's the grader, and the grader, is looking for, a graceful error message. So maybe the body of the response is appropriate to show, but probably not the error code itself.
How extensively are you going to test our project via the URLs versus your clients?
So, right, I mean, as you picked up, there are a couple of interfaces to your code. There is the command line, but there's also the REST API itself, URLs. So yes, I will be hitting the URLs directly. And so then my expectation is that, the URLs, because hitting the URLs is a valid interface, it should do all of the same error checking, so things like making sure the dates are well formatted and stuff, as your as something happens on the client side. So that's part of your program too. It's part of the interface to your program. Ha 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 ha! No, that's what you mean. Ha 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 ha. Yeah, Evil Dave, right? Because there's this guy that looks just like me. He's got like an eye patch and the goatee and everything. That's the good Dave. Anyway, been using that joke for years. Sorry. Okay, anything else on Project 4? Oh yeah, sorry, yeah.
Oh.
No. Anything else?
So the final will be in class, kind of thing, right?
Yes, final is in. Yeah, I'll talk more about it next week. I'll give you all the gory details. There aren't a lot of them, but yes, it will be in class. So yeah, all you people who haven't seen in a few weeks, yeah, please show up. Otherwise, you won't take the final.
Is it the whole class? Or the back half of that class? Or the whole. Like, what is the final class?
Oh, I'll cover cover it more in
How much
detail.
Time of the last meeting?
History shows that it's, plan on 2 hours. So yeah, set your TiVo to record Felicity or whatever it is that you do on Wednesday nights. So Felicity is also a running gag in the course. Anyway, sorry. That's for Felicity? Yeah. Anyway. Okay. Yeah. Some people do. Yeah. Right on. Okay. Anybody started Project 5 yet? Just curious. No. Okay. Well, good. We'll see it tonight. Awesome. Well, let's get started then. Okay. So the final. So all through the course, you've been building up this project that deals with phone bill, and it's got phone calls in it. And you've taken it from just modeling domain objects to writing to a file, to learning how to make it look pretty, to doing a client-server thing, and now the apotheosis, a college word, of the project, which is Project 5. You'll be writing a rich internet application for it, a rich user interface, using a framework called GWT Google Web Toolkit. And so, as you can learn about in the GWT lectures, which I think I just are here in week 5, is a toolkit that was developed by Google that leveraged that allowed all their Java engineers that knew a lot about Java to write web applications that have all sorts of fancy HTML and CSS and JavaScript without having to become experts in those technologies. And this was a big productivity gain for Google and allowed them to write a lot of code really quickly. I will say that GWT has become a little passé right now because JavaScript got better and HTML and CSS got better. So GWT was really developed back before HTML5 came out, before when JavaScript was just starting to become a respectable language, and now you've got better tools for doing your HTML and doing your CSS and JavaScript in a much more platform-independent way. I still use it in this class because it's Java. So I want to give you guys the opportunity to write something that looks like a real computer application in the year 2018 without having to have you guys learn JavaScript in like a week and a half, right? So that's why we're doing it. There are some interesting qualities about GWT, about the way the application's laid out. Because it runs, in GWT, you write your code in Java, but it runs in the web browser, and it doesn't. And it runs in the web browser as HTML and CSS and JavaScript. It's not like you run a Java plugin or anything like that. No, it's actually using the language, the tools of the web browser, namely HTML, JavaScript, and CSS. So the way it accomplishes this is that GWT compiles a subset of your application, basically all the stuff that represents the UI, the stuff on the client side. It takes that Java code and compiles it into JavaScript, much like Kotlin, come to find out. And so what it does is it creates all this highly optimized JavaScript that gets bundled into your web application. And so then when you load your web page, when you hit the web application, what you get is this JavaScript that was derived then from your Java code. So this lets you, as the Java developer, write in the languages and many of the APIs that you're used to, but what you're writing isn't a command line application or the back end of some web service. It is a rich internet application. Okay. So that's a brief overview of what GWT is. But what I want to focus on and what I want to demonstrate to you is how you work with GWT, and so how you'll be working with your project. So last week, we very briefly used the Maven archetype for Project 5 to create a GWT project. And I think I showed you sort of, hey, look, it runs, and you get something, there's a button, you can click on it. Tonight, we're going to dive into the code. But first, let me, I guess I'll just show it to you. So here in the phone build GWT directory, if we do a Maven, let's just do a clean. Always good to start over again. Maven, Jetty, run war. So this builds the entire GWT application. Another nice thing about GWT and the fact that it's in Java is that it's Java code. You can run, you can write tests for it. So you can write unit tests for the majority of the logic in your code, and you can also write integration tests that will run your application as if it's running in a web browser and interact with it that way. And so then you can you have here again one language. The tool set that you're used to, you can use IntelliJ, you can use Maven, you can use unit testing like you're used to develop, used to with Java applications, to develop a rich internet application. And so what we're seeing right here is the GWT compiler is compiling what they call various permutations of your application. They optimize the application. You can optimize your, you can have the output, the compiled JavaScript output of your application optimized for different browsers. Newer browsers, older browsers, et cetera, to take advantage of their, the tools that they offer as far as JavaScript and CSS and all sorts of other optimizations and stuff. So now I'm running a Jetty server that's running my my phone build GWT application. And so now if I go and hit this thing, this localhost, I think it's phone bill. Is that what it's called? Yeah. Okay. Cool. So same URL as Project 4, but now it's displaying a GWT user interface. And so it's got some buttons here, and I can click on the Show Phone Bill button, and it pops up an alert with some information about a phone bill. And it gets that information from the back end. So remember this picture from Project 4, where we have this is your server and this is your client. Well, there's a very similar picture for Project 4. So here, let's see here. Let's do it this way. So now this is the web browser. And in the web browser is, it'll load the page, which in this case it's /phonebill.index.html. And then this has a whole bunch of JavaScript. And that is compiled from Java code. And this is, I'm going to get rid of, I'm going to get rid of that. I'll delete that. So this is all fetched from, can I move that here? Yeah. So all that JavaScript is downloaded when you download the page. And then as you're interacting with this, oh, and that's all, sorry. And then over here, yeah, you have Jetty, but here you have, well, actually, it's a GWT servlet. So it's using servlet technology, but it's a GWT thing. And what this is actually doing is, this is the phone bill service, and we'll see what that is in a minute. And then this has a method like get, I think it's called get phone calls. And then, let's see here. Here, so when button is clicked, what this ends up doing is making a call to get phone calls. And so then, I'm pretty sure it's a post, phone call, a phone bill, and we'll just say something like magic GWT URL. And here, this is, it sends a serialized Java object. We'll get into all of this in a little minute, but in a minute. But this is the picture that I recommend that you have in your head. So again, project 3, we had a web server and we had a Java client talking to it. Project 4, again on the right, we have a web server, but now we have a web browser talking to it, and we have inside the web browser is a client to it that yes has a bunch of HTML and JavaScript and is rendering the UI, but then when you interact with the UI, that in turn is making calls back to your server to do things. And this is the way a rich internet application works, right? You've got a single page, essentially user interface that has lots of JavaScript to then interact with the server. So the page itself doesn't reload, right? So this isn't Amazon circa 1999, where it's like, oh, CGI URLs, right? Remember all that stuff where like every time you interacted with the page would reload? It's not like that anymore. It's one page load, and instead in the background, the web application running here on the left interacts with the server on the right. Okay. Now let's walk through some of the source code. Here in phonebuilder.gwt, we'll go into the Java code again. The source code in a GWT application is divided into two packages, one for the client side and one for the server side. It's the client side code that is compiled into JavaScript. This is why they make a difference between the two. Your server side can be doing whatever a Java application can. It runs there in the servlet, right? So it can access the database. It can write to the file system, all that good stuff. Because this is going to be running inside a Java virtual machine. The client code, though, because it gets compiled into JavaScript to run in the browser, has a bunch of restrictions on it. There are a bunch of things that it can't do. So, for instance, it can't access the file system. Can't use the Java IO file object because the browser can't access the file system directly, right? That's not secure. Same thing with opening sockets, all of that good stuff. What GWT does, though, is it defines a set of APIs that are basically safe to use on the client side. And the way they make it safe to use is that they implement a JavaScript implementation of these APIs. So APIs like stuff in Java util. So you can use an array list in your client-side code, and the GWT compiler will basically say, oh, this is a Java util array list. Great, I've got a JavaScript implementation of that. Use that instead. But to you, the author, the programmer, it's just a Java util array list. So that's kind of the cool thing about what happens on the client. Now, also on the client side are you need to represent what your user interface looks like. Now, this user interface is pretty simple, right? It's got a bunch of buttons. It's got some text in it, and then it's got a bunch of buttons. So let's see here. That text, I believe, is specified in, yeah, this phonebill.gwt.html. So HTML, hypertext markup language, is the is the rendering language of the web, right? So this is how you specify text in it. Well, yeah, the body of your web application of your HTML. And so then this is the file that gets loaded when you go to when you access this URL. It loads this guy, right? The title is a phone bill in GWT, and sure enough, if you hover over this, a phone bill in GWT, right? So no magic here. It's just that, okay, it's loading this. Okay, I'm sorry. There is some magic, and the magic comes in this JavaScript that you load. So this is the JavaScript that is compiled from your Java source code. And so we saw this last week, but I think it bears repeating. Sorry, wait. Oh, yeah, view page source. Okay, so here's that HTML. And now I can drive into here. And here is some obviously machine-generated JavaScript. This is, I think, set to pretty readable mode. That basically is the thing that when loaded. So I don't know, is there an onload call or something? Let's see here. I don't remember exactly how all of this works because it doesn't matter. When this page is loaded, that JavaScript is invoked to then create all of the UI widgets that are on your page, such as all these buttons. Okay. Let's then look at the source code that creates all those UI widgets. So, where do I want to start? I want to start on the OnModuleLoad. Okay. So, in GWT, or at least for what we'll be seeing in Project 4, you write Java code to create your user interface. And kind of like what we talked about last week during the design patterns lecture, GWT has a class hierarchy for a Java class hierarchy for representing different kinds of UI widgets. So there's a class that represents a button. A class that represents a text field. There's also there are also classes. There are also objects, classes and objects that represent various algorithms for laying out widgets on the page. So for instance, you can say, hey, I'm going to use a vertical panel here. And so the vertical panel is a piece of screen real estate that has children widgets that will lay them out in a in a vertical stack, up and down. Similarly, there are panels that will lay themselves out horizontally. Ones where you can there's like 5 children widgets, one in the center, and then north, south, east, west. All sorts of and so all these different pieces, parts that you can then combine and put together to lay out the application that you want to lay out. And you represent all of these as Java objects. So it's a little different if you've done like layout with CSS, where it's more about doing it in markup, where you say, okay, great, here's my div, and I'm going to set some style on it, or give it a style class, and it shows how to outlay everything. Here, it's all done with Java objects. Now, in projects 1, 2, and 3, what code was invoked when your program started? Main, right? Your main method, right? And so what you did is you started JVM, you told the JVM, hey, here is the class that contains my main method, and your program started. Poof, okay. In project 4, on the server side, how does your code get invoked, or where does your program start?
The function got called from some of the code you wrote.
More specifically,
Well, there was I looked at some of it. There was an intermediary between the REST client and the servlet itself.
Right. Yes. So in project 4 on the server side, you started Jetty. And now Jetty is written in Java. There's a main method there someplace. You didn't invoke it directly. You had Maven do it for you, but whatever. It runs the main Jetty program. And so that starts up Jetty. And one of the things that Jetty does is then looks for web applications that are deployed in it, creates your servlet, and then your code is not invoked until someone hits the right URL. Okay, now your code is invoked. In GWT, on the client side, instead of there being a main method, because you're not really running a program, instead there's a method that's invoked when your page is loaded. And that's called OnModuleLoad. And so here in our phone bill GWT class, it's kind of like our main class that begins our GWT client side program. The first thing that that is called on it is onMainLoad. And then this is the thing that creates and sort of starts up your web application. So there's a little bit of stuff here to properly handle exceptions. I'm not going to go into details about it because what I hope you'll do is just like leave it alone. Because exception handling, GWT has some nice features for it, but you have to configure them, make sure everything's set up correctly. So leave that alone there. Instead, really, where the interesting stuff starts is the setup UI method. So what setup UI does, and this is a private method, this is unique to this class, is it says, okay, great, I am going to, ultimately, what this class does is it creates all the widgets in your GWT client side program, client side UI, lays them all out, gets them all pretty looking, and then registers event handlers, and we'll see that in a little bit. And that's it. Actually, I'll talk about that now. So project 4 was different because it was a distributed application, right? You had two JVMs talking to each other, and probably the first time many of you had seen that in the environment, that kind of environment. Writing user interfaces are different from command line applications, most command line applications, because the interaction with the program is asynchronous, right? If you think about your project 1, you type out your command line, you hit return, it runs the program, takes the input, it does whatever it does with the input, writes the output, and then it's done, it exits. That's it, it's done. Your web server, on the other hand, was a little different, right? You start the program and it sits there. It sits there waiting for someone to hit the URL, and then it'll handle that response. It handles that response, but then it sits there and waits for the next thing. A UI is similar in that, well, the UI starts up, it displays itself, and it's waiting for someone to interact with it, right? It's waiting for someone to click a button. It's waiting for someone to scroll. It's waiting for someone to type some text into a text field. And so, because the nature of the user's interaction with the program is, I know there are flies in here and pterodactyls. I don't know. It's very distracting for everybody. Because the user interacts differently with the program, with the UI, the code for the UI is different. The code with the UI, there's basically the first thing that it does is it sets everything up, but then it needs to handle the interactions with the user has with it. And so what you do here is not only do you create a button out there, but you also configure the button to say, oh, when the user clicks you, go off and do this. And remember, it's when the user clicks, not right now. So it sets it up in one phase, and it says, oh, but wait, when there's interaction with this UI widget, go perform this operation. That's a different mode of programming than probably most of you are used to, and it adds another level of complexity to how you then work with this code. Because as opposed to what we're all used to is you start here and you sort of read down, and that's all going to be all your code. It's like you start here, you initialize some stuff, but then at runtime, oh yeah, right, the button's interacted with, and now this other method's called, and that interaction initiates with the user interacting with the button, as opposed to just the program running to that line of code. And so we'll see how that's handled here also. So when we set up our UI, we first get what's called the root panel, which really represents like the entire web page right here. And we put a new, we make a vertical panel, which will contain all those buttons. Add that vertical panel to the root panel, and then we call it an AddWidgets method, which just keeps things nice and small. So what the AddWidgets method does is it adds the 4 buttons to the UI. These buttons are all stored in fields. Oops, are all stored in fields like show phone bill button. So that show phone bill button is a new button. It's got a title. I don't know what you call that exactly. What do you call that? That is okay. It's called HTML. Not a very insightful name. And you create this button here. You create another button here. We'll come back to that add click handler later. Anyway, you create 4 buttons, and then you add them all to your vertical panel. And sure enough, they all get laid out in a vertical column, because that's what vertical panels do. In addition to creating the button, you need to tell the button, here's what I want you to do when you're clicked. And the way you establish that interaction is by adding something called a click handler to the button. So you say, hey, button.addClickHandler. Click handler is an interface. Can I use lambdas yet? Maybe I can. That doesn't help though. It's an interface. What you can do is you can create an anonymous inner class, and I think we talked about these before, but there's certainly lots of coverage of them in the lecture. And that says, hey, listen, okay, when that button is clicked, call the show phone bill method. And actually, I'll get back to that later. So for each one of these buttons, I register what's called a click handler, which does which performs some operation. So for show button, it'll show a phone bill, and then I have all these things that show what goes wrong when or what happens when various kinds of exceptions are thrown. And that's it. That's all the AddWidgets method does. So step 1 of building your UI, you create all of the widget objects, you add them to the appropriate panels, the appropriate containers that will lie them out in the right way, and you register all of the event handlers. And that's all the setup work that needs to be done. And now, basically what your program is sitting there, your UI is sitting there, waiting for something to happen. So like when I click show phone bill, okay, this pop-up happens. Yes?
So being as this UI and it's like a whole class in itself, the UI, UX kind of stuff,
Mhm.
so are there ways for us to control like the size of the bar and like, is that all
Yes.
stuff we're going to get into? Am I just
Not tonight. It's all there in the Java doc. So what I'm going to cover tonight are really sort of the nuts and bolts of the code to get you started there. But I encourage you, again, use your creativity to make a phone bill application with a pleasant user experience. I'll say that much. And yes, you can customize all sorts of good stuff, including colors and layouts and sizes and fonts and no blink tags, please. But all of that is configurable. The GWT has good online documentation, and there's also API documentation, for all this stuff. And so, as you can see, oops, come on, really? Oh, there we go. I was going to say, are there interesting set methods? Yeah. You can set the size and text and visible and all sorts of good stuff like that on all of these objects. So I'm just going to do a check. Again, 3 steps for creating a UI. Instantiate your objects, instantiate your widgets, lay them out into panels, and register event handlers. We're going to look at what the event handler does next, but I want to pause there for questions. Yeah.
Is it fine to just do like the vertical panel for our UI? And like, do you want us to have like the history state management thing in there, where if you're like jumping around between views, you actually, if that button works, and take you back across the
I'll answer your second question first. Do we need to implement history with the back button? No, that's not going to be a requirement. It's kind of an advanced topic in GWT. If you want to play with it, great, but make sure you've got everything else working first. Okay. And as far as you said, hey, can I put the whole layout in vertical panel? It'll probably be pretty ugly if you do. So, and part of the assignment, yes, there's the eye of the beholder, and then there's just ugly. Come on, man, right? It's like minimalist. You're gonna like exhume Steve Jobs. He's gonna like, this is the greatest UI because like you have like 27 text fields that are all laid out in it. Yeah.
More than like vertical, for each functionality, and then you have like a view.
Yeah. Here again, part of the assignment is to be creative, and then part of the assignment is also to explore GWT's tools for laying out widgets. So I don't expect like a Google or Facebook level like just oh it's so usable, it's so beautiful, and everything like that. But I want something more than just like, hey, I took your code exactly, and I just keep adding more things. I want evidence that you explored the API. I want evidence that you had an idea of what the UI should look like, and you attempted to do that.
It's pretty hard. So.
What?
Pretty is hard.
Yes, pretty is very hard, and I'll take homely, I guess. Yeah, GeoCities, yeah, maybe retro. I don't know.
But we
Yeah,
just put Starry Night in the background and
yeah. I've had students that have done stuff like that, and yeah, Starry Night would be okay. Yeah. Okay. Actually, those were good questions. Any other questions before we move on? Okay. So, well, let's see here. Okay, before we move on, I want to show you something else. One of the neat things about GWT is that they wanted to enable, well, one of the nice things about like working in JavaScript is that you make a little change to your JavaScript, you reload your web browser, and poof, like you see your changes instantaneously. With Java, you usually don't have that. You have to go recompile your classes. If as you probably learned in your project 4, you make a change to your server. You need to bring down your server, recompile it, bring it back up again. It's kind of slow. GWT has this mode called Developer Mode that runs your GWT application in a way that it can be in a way such that when you make changes to your Java source code, it will you can just reload the page and they'll automatically show up. So apparently it's computing the startup URL. Oh, I don't like that. Oh, interesting. Ooh, hope that works still. Okay. Launch default browser. So GWT development mode brings up a little application that sort of runs. So instead of like launching Jetty separately, it runs in that little application there. You can launch it. Notice it runs on a different port, but it still does the same thing right there. And now, if I do something simple like, see here, show phone bill to everyone. And now if I reload my page, it recompiles it, and now you see the result. So as you're adding more widgets, as you're moving things around, you run in development mode, and you can see your changes really quickly. That's neat. Actually, let's quit out of this, and now if I run GWT debug, that runs development mode again, but it runs it in debug mode, so that, let's see here, on port 8000. So now you can attach in IntelliJ on port 8000, so add a new remote, and oh bother, remote. And this will be GWT dev mode on port 8000 on localhost. Now you can attach and debug. Good. I'm there. Now it's doing the whole thing again. Let's see here. Now if I reload. Okay. Oh, I should have. Actually, here. I'm going to set, let's, I'll just put a breakpoint there. Now if I reload. Oh, it didn't stop at the breakpoint. I'm disappointed. Okay, so it's definitely debugging. Why didn't it stop? Aw, GWT, you're breaking my heart. Why is debug mode? Yes, question. No, I'm attached. I'm attached. So shouldn't need to do that though. Okay, it's in suspend mode, so I will rerun that. So it went away. It's attached. It's running now. Oh, I wonder if it's not letting me debug the client side, only the server side. Okay, I'll need to figure that one out then. I know I've had problems with this before. Right. Never mind. Yes, of course you can't. Because the following. So, okay. One of the changes they made a couple releases ago was they're like, browsers, especially Google's browser, has good support for debugging. So you don't need to debug on the server side anymore. You can debug in the client side. And so then if you go use the developer tools, you can look at, you can open file. Neat. Oh, that's not what I wanted though. Phone bill. Is that? Oh, come on. I'm looking, oh, wait. Used to be. Ah, I am unprepared. Huh. Oh. I got a 500. Oh, it's getting a 500. Interesting. What is it like? Yes. Okay, so something is screwed up on the back end. Oh. What didn't it like? No, it's not. Phone bill is not assigned to is serializable. Say what? Of course it is. Okay. Okay, well, it used to be, and I need to go check this out, it used to be that you were able to debug here in the browser, and I don't know why it's not working tonight, and that is super, oh wait, here we go, source maps phone bill. Yay, okay, good. Okay. Yeah, this is how you debug. So, the cool thing is that GWT gives you this view of your JavaScript code as Java. So it has all sorts of neat things here. So let's go find our setup UI method. Let's see, can I navigate into that? Maybe I can, but not so easily. Here, okay, cool. So let's just set a breakpoint there. Let's reload the page. And there I am. So I'm using my client-side JavaScript debugger to debug, yeah, my compiled JavaScript, but it's giving me the view of my Java source code, which is sort of the right thing for it to do. So yeah, now I can navigate through all of this stuff. Let's see here. What is it, F11 these days? Oh wait, step over is F10, so it's F7, 11. So now I can do all this stuff, and I get a debugging experience here from the JavaScript debugger. So that's super nice. And so then I'll walk through what happens when you interact with your UI. So right now, sorry, and let's continue, F8. Oh, why is it different from IntelliJ? So now it's loaded. Now I will debug what happens on the when you click a button. So I'll just set the breakpoint here for my onClick method. So now when I click the, here my onClick. So when I click the button, it calls this show phone bill. I will step into using F11. Here I am in phone bill. Okay, I'll log the output. Nice to know. That shows up here in the browser's log. And now I'm going to make a call to the server. Okay. Oh, I should be running the server in debug mode. Okay. So this is another interesting thing about GWT. In Project 4, how did your Java client communicate with the Java server? Through a URL, yes. And so what your Java client did, your command line client via the phone bill REST client class, most likely, is that it went and fetched a URL. And how did you send? How did you express the data that you wanted to send back and forth?
In a array of string, string array.
Yep. That ultimately got translated into what for the URL? Parameters, right. So for the get, it was stuff, key value pairs after the question mark. For the post, it was key value pairs that are in the body of the post. And so your code or your code using my code had to do all of that work because it's communicating over HTTP. GWT applications also communicate over HTTP. But what was one of the things that sucked about Project 4? I'll answer for you because I'm sure there are many answers. One of the things that sucked is that your programs are used to dealing with what kinds of objects? What types of objects? Phone bills, phone calls, dates, right? You're happy with all those stuff. What does HTTP communicate with? What language? What data does it use to represent its stuff? Strings. Everything's a string. Right, so you'd convert your dates into strings. You'd convert your phone calls into strings. Your phone bill into strings. What a pain in the butt, right? You had to do all of that. GWT takes care of that for you. So in GWT, when you communicate between the client and the server, you can use objects. So you can send objects back and forth. And GWT implements something called object serialization, which will take an object that plays by certain rules and automatically convert it into some string representation that can be sent back and forth between the client and the server. So what you do in GWT on the client side is that you have this object that represents what's called a service, another object, on the server side. And that service exposes methods that you can invoke on the client side and set it to objects. Those objects are then serialized into strings, sent over HTTP to the server side. The server then takes that payload, deserializes it, excuse me, into a Java object and delivers it to your code. So this makes it much easier for you. So let me quick show you. Actually, here I'm going to do this again. I'm going to let it run. And now I'm going to bring it down, and I'm going to bring it down. Now I'm going to run it in debug mode. And I'm going to attach on the server side. Okay. Now, back here in IntelliJ, on your server, there is something called phone bill service impl. This is it's called a GWT service. A GWT service is an object that is exposed by GWT that you can then work with on the client. The service provides methods that can be invoked remotely by the client. And these methods, well, this is the communication interface between your server and your client. This example has several things. The most important, most interesting one is get phone bill. So here's a method on your server that says, okay, well, here's the phone bill that we're dealing with, poof, and sends up the phone bill. This is code that you write. This is simple code. It says, okay, great, create a new phone bill, add a phone call to it, and send it back over the wire. That's all you need to do. So all that string manipulation you need to do in Project 4, converting, taking your phone call apart and like putting in all these parameters and stuff, nope. GWT takes care of that for you. It's also got some examples of dealing with exceptions. Maybe I'll get to those later tonight. Maybe I won't. It's not terribly important. So this is equivalent to your doGet method, right, in Project 4. Your doGet did stuff like this. Oh yeah, right, return me the phone call. And remember, your doGet was on a servlet class. And as it turns out, this is also a servlet class. Not a lot of magic here. It's just a servlet that is a special GWT servlet that allows you to express your interactions not using like the sort of the primitive servlet methods like doGet with the HTTP request and HTTP response. Instead, it lets you express the interface between your client and your server using Java objects. It's a win. It's less code, and it's easier to reason about. So this is what your service provides on the back end. Invoking the service, though, is a little unusual. So remember how we were talking about, I was talking about, you were listening, I'm sure, a little while ago, about how the nature of the interaction between the user and the UI is different than like a command line interface, where the UIs are sort of sitting there saying, hey, someone please talk to me. And as a result, you have this asynchronous communication. When you click on a button to do something, think back to probably like when you were in elementary school and were using like a really old computer. Did you ever use a program where you like clicked on like save or like fetch something from the internet and it froze? Right? Why did it freeze when doing something like reading a file or fetching something from the internet? It couldn't find the file. It was taking a long time to do something, right? And your app froze, right? If you tried to click on other things, it wasn't responsive. Is that good behavior? No, it's not, right? That's not a pleasant user experience. You get a little, spinny ball of doom, or it just like, freezes up. So instead, what you want to do is that when you've got an operation that might take a while, and a while in terms of the user's responsiveness. So like a good rule of thumb is anything that might take more than like half a second. You don't want to do that as part of handling the event, as part of the user click. Instead, what you want to do, kick that off in the background, and then when it completes, tell the user that it completed, right? And so, like here again, like downloading, a big file, a big picture, or something like that. You click download, and the way you want to handle that is say, okay, great, go download that in the background. The user can still interact with the UI, do other things, but then gradually render it. And don't block the rest of the UI. So this means when communicating between your client and the server, you do it asynchronously, meaning that, oh yeah, you start it, but then you go on and keep handling other user interaction, and then in the background, when that background task completes, then your UI will be notified of it, your client-side code will be notified of it, and then you can handle it appropriately. This means, from a programming standpoint, that when you click the button and when you want to interact with the server, it's not just a matter of calling the method, calling the remote method. Instead, what you need to do is you need to go say, oh yeah, invoke that method in the background, so go make the request to the server, and when that background request is done, go execute this kind of code, the specific code. So it's like, yeah, go fetch the phone bill, oh, and then when the phone bill comes back, okay, render it in an alert dialog. The way we represent that in Java is as follows. So, the show phone bill method does this thing. Okay, so it gets the phone bill service. Oops. And we'll see what the phone bill service is in a second. The phone bill service is a client-side proxy, a client-side representation of your server-side phone bill, of your phone bill service impl over here. And you call a method called getPhoneBill, but it's not the same not exactly the same getPhoneBill that's on the server side. It's instead a method that takes an object called an asynchronous callback that returns a phone bill. Asynchronous callback is an interface with two methods, onSuccess and onFailure. Oh yeah, another thing that you need to be able to handle is what happens when something goes wrong when communicating with the back end. Right? So, oh, there's an exception. Oh, the request time's out. Oh, there's some problem. You want to be able to handle that. You want to handle that separately. Versus the happy path, which is like, okay, yep, I called that method. Oh, here's the result. Now do something with it. So, when you invoke one of these back-end calls, one of these calls to the server, you say, okay, great, I'm going to give you an async callback. And the async callback specifies two things. What to do when there's a failure. In this case, I'm going to alert with the exception. And you actually get you get an exception object that's delivered to that callback. Alternatively, again, this thing runs in the background. When it's done, it's going to invoke this onSuccess method with the phone bill that's returned from your server-side method over here. And you're going to print it out. So you're going to create a string builder. You're going to iterate over the calls in the phone call, append each one to the string builder, and then you're going to pop up an alert with that. So now, I set some back. These are never mind. This is all client-side code, so these breakpoints aren't going to work. Question.
So it's fine to communicate with the user through alert boxes.
It's fine in error messages. Yes. For this simple example, yes. For yours, no. Pretty print the phone bill in something that looks nicer than a dialog box. What?
Like into the web page.
Yeah, into the page, into like a text area or not a label. What are they called? Yeah, or a panel or something like that. Yep. Yeah. So tonight, I'm going to be focusing on the mechanics, basically, of what you get from the archetype. Please watch the GWT lecture because that's where I go through the phone book of here's all the different kind of widgets and here's all the different kinds of layouts that you can leverage. That's really important too. I'm just focusing on one aspect of it tonight. I'm going narrow and deep tonight. The lecture goes way more broad. So I'm going to set some breakpoints here. I'm going to set a breakpoint in the back end. And let's see here. I am debugging, right? Yes, I am debugging. And here on the front end, I set a breakpoint here on the onSuccess method. Actually, I'm also going to set a breakpoint here, I guess, which I guess I already did. Okay. I might need to reload my page. Okay. Oh, cool. Here I am in the debugger. Great. I'm setting up. So I will continue. Now when I click phone bill, okay, show phone bill, that's neat. I'm going to debug into that. I'm going to print that out. Okay, so phone bill service.get phone bill will then invoke will make the call to the back end. Poof! Now I'm stopped here in IntelliJ in the back end. So this is Java code. Okay, let's go back to the picture. Doing a whole bunch of JavaScript stuff on the front end, even though it looks like I'm debugging Java code, it's really debugging JavaScript. I just clicked the button, which then called, actually it's not get phone calls, it's get phone bill. On the back end. Okay, now I'm here in Java world. This is on the back end, right? This is in Jetty. And I can debug this. Yep, great. I got a phone bill. It's my Planet Now, same old phone bill class. And now I've returned that. And I'll continue on. I'm just here in GWT land. Not terribly interesting. Now if I go back to Chrome, and I go back to the right tab, one of my millions of tabs, pause and debugger, so continue on. Now, the call to the server has returned. I'm here in my onSuccess method. Now I'm back on the client side. I will construct my let's see here, call stack, watch. Wait, can I just evaluate here? I don't remember how to use this exactly. Local, there we go. String builder. There it is. This is the string that I have created, my string builder. I'll give it a little bit more screen real estate. It's all there. And notice that GWT, at least in this mode, gives you pretty good like variable names and stuff like that. You sort of know what you're dealing with, even though here again you're debugging JavaScript, but it tries to give you as much of a Java feel as you can. And now I'll call the alert dialog. The alert pops up with that string, and then I'm done with that method. And then yeah, I'm back in like GWT land, and I continue and I move on. So, communicate. So, these are some of the complexities of GWT. Yes, you've got a lot of Java code, but the way you had to learn some rules about GWT, but the rules help you in the end because boy, this is a lot easier than having to convert all of your phone bill and phone call into strings and send them back and forth between the client and the server. I want to take a break. We'll come back. We'll talk some more. We'll sort of do a review, and then we'll move into the kata. Okay, so 10 minutes.